All right, so with this question, the cosine 2x, that is a double angle, and there are double angle formulas for cosine 2x, but the thing is nothing is going to cancel out somehow with this e to the x. So the only way to deal with this is that you got a variable over a variable, so you need to use the quotient rule. So our top function is e to the x, the bottom function is cosine 2x. Top function's derivative, e to the x, is just e to the x. Bottom function's derivative, here we don't just have cosine x, we have cosine 2x. So we need the chain rule there, and so we will take the derivative of cosine, that gives us negative sine, keep the inner fixed at 2x, and then multiply by the derivative of the inner, which is just 2. And then to simplify things, just bring the coefficients to the front, so we have negative 2 sine 2x. And what I personally would do is, like, these parentheses here are just for your emphasis that that's the argument. They're unnecessary, so I would drop them just so that there's fewer parentheses when we plug it into our quotient rule. So we have, excuse me, we have a top function and its derivative, and then bottom function and its derivative. So plugging into the quotient rule, we start with the bottom. So we will have y prime is equal to cosine. Again, the parentheses here around the argument are unnecessary, so we can drop those. So that is our bottom function, times the derivative of the top, minus, and then our second diagonal, e to the x, and then negative 2 sine 2x, all over the bottom squared. So cosine 2x quantity squared. Now, before you start distributing everything, I would look before and after this main subtraction sign and ask yourself, is there anything in common? And we see that the GCF of e to the x we can pull out. So we would take out that e to the x. When we take out the e to the x here, we'll be left with cosine 2x. Now here we take out the e to the x and we're left with a minus times a minus, so plus 2 sine 2x. And then that is over cosine. Now remember, you can write it as parentheses 2x or parentheses cosine 2x squared, or you can write this as cosine squared 2x. So either are perfectly appropriate formulations. So that would be our final answer with our GCF factored out.